This is the science of stupid. Warning! Like any rules, if you try to break the laws of physics, you'll suffer the consequences. So don't try anything you're about to see. Yes, this is the show where science and stupidity collide. In a cacophony of chaos, you'll see backyard experimenters push themselves and science to the extreme, often with painful results. Then we reveal what went wrong and why, with the help of such scientific principles as trajectory, circular motion, and positive feedback. So strap yourselves in, because this is the science of stupid. In this show, we'll explore skateboarding's relationship with angular velocity, snow's low coefficient of friction, and how confetti cannons relate to kinetic energy. But first, this. Whipped by wind, battered by waves, and weather-beaten over hundreds of thousands of years, cliffs are formed out of hardship, and it shows. The world's highest cliff is generally agreed to be the Rupal flank of Nangar Parbat, Pakistan. It rises over 2.8 miles above its base, which is almost 50 times higher than this one in Ireland.
Oh my gosh. You gotta hold it for 5 seconds.
And one would imagine 50 times scarier. But a mistake on even a smaller cliff could prove to be fatal. Which is why cliff jumping is never recommended. Some of the most awe-inspiring landscapes on Earth are dominated by cliffs, and the science behind them is pretty impressive too. A rock cliff is able to maintain its structure and shape due to the properties of the rock that make it up. A coherent body of rock has rigidity with very high compressive and shear strengths. However, over time, certain environmental forces can act to wear away at the rock. Weathering and erosion by wind, water and ice can gradually affect even the most rigid of rock cliffs. And the rock's own weight, or the weight of something else, can then overcome that strength, causing it to fall and the cliff to retreat. It's worth noting that cliffs are not only breathtakingly impressive, but also potentially life-takingly deadly, so it's best to err on the side of caution and enjoy them from a safe distance. Although I don't think this guy has heeded my advice. In fact, that is exactly the opposite of what I just said. This coastal cliff has been eroded by waves to the point of leaving a natural arch. When the cliff jumper pushes off, he applies a force to the rock with his feet on a section that's already experienced significant erosion. This force is enough to overcome the remaining shear strength, making rocks join the diver on his descent and making that cliff retreat slightly. Of course, being at the base of a cliff can be just as dangerous as being on the top of one. See what I mean? If the action of waves against the edge of a cliff can erode solid rock, then that kayaker doesn't have much chance. And because he can't just flow like water can, that is going to sting. Erosion is, for the most part, a slow and iterative process. A tiny crack may form in the rock surface, and water or ice can penetrate to dissolve or apply force to widen and lengthen the crack. This can leave the top of cliffs rather uneven. If only someone had told him what a terrible idea that was.
Bad idea? I think it's time you start listening to your little brother.
Oh, they did. Because of the iterative process of erosion, what starts as a tiny crack is widened and lengthened over time, making its surface uneven. Which fortunately gives it enough friction to stop him slipping off the edge. So that's cliffs, majestic and best enjoyed from a safe distance. This cliff is heavily undercut into a cave, allowing boats to go through, information that would have been useful to know before he jumped and broke his arm. Still, he got off lightly, so don't try this yourself.